We are going to get started right away with Chapter 1. In Chapter 1, we'll cover equations, inequalities, and mathematical modeling. And mathematical modeling is just applications, using your math skills to model a situation. The objectives for our first lesson here, which I split into a few videos, is sketching graphs of equations, identifying x and y intercepts, using symmetry to sketch your graphs, writing equations of and sketching graphs of circles, and then using graphs of equations in real life problems. So that's your mathematical modeling. Now you've done a lot of this already. Most of Chapter 1 will be review, but that's a good way to get us started. Starting off here, talking about graphs of equations, solutions of equations, we have the relationship between two quantities can be expressed as an equation in two variables. You've worked with these a lot. So an example that we're given, y equals 7 minus 3x. We have the variables y and x. X is our input, y would be our output. And then in terms of solutions, we can check our solutions, which is always very important with math when we're solving, because we know a solution is an ordered pair, x, y, we could call it a, b, it doesn't matter. But when we substitute those values in, it results in a true statement, and that's how we know it's a solution. So the example that they have here is that 1 and 4 is a solution of our equation that we were given, y equals 7 minus 3x, because if we substitute the 4 in for y and the 1 in for x, we get 4 equals 7 minus 3, and we know that, sorry, this 4 kind of looks like a y here. There we go, and then that gives us 4 equals 4, so we know we're good to go. So we're looking for true statements if it's a solution, and we can find those solutions in different ways. So we can use the graph of our equation, and that's the set of all points at our solution. So we can find lots of different solutions by using our points on our graph. The point plotting method. Now, I don't think we've ever given it this name before, but you've definitely used it before. So if you go through the steps here, when possible, isolate one of your variables. So solve for y is what that means. And then construct your table of values showing the general solution points. And that's where it's really common for us to choose -2, -1, 0, 1, and 2. Plot your points, and then connect your points with a smooth line, or it could be a curve. Keep in mind we're not only talking linear here, so it could be a curve as well. And then it is important, we've got our note over here, to use some negative, some 0, and some positive values when you're creating your table. So these -2 to +2 is a common choice. However, they're not always the best depending on what the graph is. So if we go ahead and we complete this table of values using our equation that we're given, if we have -2, we'd have y equals 7 minus 3 times -2. So that's 7 plus 6, because -3 times -2 is +6, and 7 plus 6 will give us 13 for our first value. And if we just continue on doing that, our next x value would be -1. So 7 minus 3 times a -1 is 7 plus 3, which is 10. Our 0, 7 minus 3 times 0 is just 7 minus 0, so we get 7 there. And our 1, 7 minus 3 times 1, and we can use our calculator on these too, 7 minus 3, so that'll give us 4. And last, put our 2 over here, y equals 7 minus 3 times 2, so 7 minus 6, and we know that is 1. So once you fill out your table of values, then you just want to make sure that you scale your graph. So look at how high your values go and how low your values go. So our x values are only going -2 to +2, but our y value has to go all the way up to +13 and then down to 1. So what I would do for that is I wouldn't even use this graph like I have it set up. I would draw it so my graph goes higher up to 13, because I don't have to go very low. So if we do that, here's what I would do. I would draw a graph where my y-axis is taller going up, so I can go up 1, 2, 3, 4, 5, 10, 11, 12, 13, because I only have to go to +1, and that covers everything. So base your graphs on the numbers that you have. You don't always have to use a generic one like I gave us here. So we don't necessarily need that one. It's not necessarily the best for us. And then our x values go just to +2 and -2. So if we plot our points, -2 up to +13. Be up here, and then -1 to 10. 0 goes to 7. And then 1 goes to 4. And 2 goes to 1. And we connect our lines. In this case, we have a straight line. We don't have any curves to deal with. But there we go. So, like I said before, very familiar. Just some things to review and talk about drawing our graphs and being precise. And then if we look at the next slide here, it gives us a full example of kind of the exact same thing that we did. This is an example that comes straight from your textbook.